Hi there, I'm Tim Autry, and welcome to Principle-Based Performance Improvement, where we combine timeless wisdom with modern science and practical tools to help you move yourself and your organization toward better, safer, and more productive outcomes.
Now, in this episode, we're going to talk about how human performance follows a different set of rules. Different from what? Well, what a lot of organizations have been guilty of, and really all we've learned a lot, to a large extent over the years, is how to fix stuff, how to fix things. And so in organizations, particularly larger organizations, we accumulate data, we make some choices or decisions based upon that data. And a great example would be, let's say you have a big piece of rotating equipment, for example. And you start to notice that the vibration's going up on this piece of equipment. Or if you have temperature sensing points, you notice that there are a couple of temperatures that are going to go up. So what you do is you allow the data to record, you accumulate data, you might do some additional data points and you put it all together and you say, okay, we know what's going wrong with this piece of equipment, we need to replace bearing number 6, something like that. The problem is, lots of organizations have attempted to use that same approach to fix people. And as I've mentioned already, you can't fix people. The great news is people don't need fixing. All we need to do is learn how to tap into really just a simple handful of intrinsic human characteristics, positive ones, align those with the why of the organization, and that's where the quote-unquote magic happens. But it's not magic at all. So we're going to start developing that now. Who is this guy? Well, most of us recognize that this is Newton, right? And he's looked upon as the father of classical physics. Now, in classical physics, those are the physics of how matter relates to matter. So then along comes this guy, and you probably recognize him from the caricature. This is Albert Einstein, most famous for this little formula right here, E equals mc squared. What Einstein was able to mathematically prove is that energy is equal to mass times the speed of light squared. And because of Einstein's work, we know that everything is energy. Now, this was 1915. 1918, this guy comes along, a German theoretical physicist by the name of Max Planck. Max Planck won the Nobel Prize in 1918 for being able to mathematically develop the next level of physics, which a lot of us affectionately know as quantum physics. And if you've ever attempted to study quantum physics or listened to a quantum physicist talk, it's like, oh my gosh, this is a whole different language. You know, it's like Alex, our IT guy that works for our company, a super smart guy. And he said to me one day, he said, yeah, he says, whenever I have a problem, he says, I go into quantum physics and string theory. And I'm like, okay, I don't even know what that means. But anyway, here's the point for our discussion, though. So Newton was classical physics, matter to matter. Einstein is matter to energy. And because of him, we know that everything is energy. What Planck was able to mathematically detail is that when you look at those atomic structures and you go down deep enough, when you get to the smallest elements, all of the rules change. And that's what quantum physics is all about. So before we go any further, I want to ask you a quick question. If you think about your team, your family, your department, your organization, whatever it is, what is the smallest single coherent unit in any of that? It's a human being. And when we get to those smallest elements, all the rules change. That being said, as I mentioned, if you have ever listened to a quantum physicist attempt to describe how it works, like for example, everything's happening at the same time. Really? Well, okay then, I can't wrap my mind around that, but a quantum physicist can explain to you how that is true. So, this brings us to this guy right here, Oliver Wendell Holmes, Jr., Supreme Court Justice in the United States back in the mid-1800s, looked upon as one of the brightest minds of his time. And here's what he had to say about simplicity and complexity. He said, I wouldn't give a fig for simplicity on the near side of complexity. However, I'd give my right arm for simplicity on the far side of complexity. What was he saying there? He was saying, look, don't give me a bunch of kitschy little phrases and just handle it, or just lighten up, or get a clue, or think outside the box, or one of those things we've all heard over the course of our lives. Give me something that's simple that I can understand, that actually has meat to it. And I'm telling you right now, for the rest of this course, that's exactly where we're headed. And this next-gen approach to performance improvement is a tremendous amount of simplicity on the far side of complexity. So I'm going to give you an example of what I'm talking about here, because really, I mentioned earlier, it really comes down to properly acknowledging and leveraging a handful of positive intrinsic aspects of human nature and aligning those with your corporate or team why. That's really what it comes down to. So let me ask you this. What's the significance of this number here? 26. I'm going to give you about 2 seconds to come up with an answer in your brain. Some of you got it. It's the number of letters in the standard alphabet. Very, very good. All right, how about this number? Now that you know where we're headed with this, you got it. The number of digits. So think about this before we go any further. 26 letters, that's all there are, and yet in different combinations, you take those same 26 letters, you got every masterpiece that's ever been written throughout human history, right? There's only 10 digits, 0 through 9, and yet with those same 10 digits, you can do any mathematical calculations, all the way up through differential calculus and beyond into that woo-woo land that I've never seen any practical use for. If you're a mathematician or if you're into that stuff, I apologize for that. All right, how about this one? And this is not number of days in the week. That's a common answer we get when we're doing this in a classroom. Any ideas? Absolutely right. It's the number of musical notes. Think about this. There's only 7 of them. And yet, when you put these together in different combinations and different timings, you got every musical masterpiece that's ever been created or ever will be created. Same 7 notes. 26 letters, 10 digits, 7 notes, and this last one is only 3. And this is the number of primary colors that we have. There are only 3 of them. And yet when you look around you, you can see probably wherever you are, you can probably see 100 different colors or nuances of colors. Every one of those is some combination of these 3 primary colors. Now, wouldn't it be cool when we're talking about a different set of rules and taking performance from where it is to where we want it to be, personally and corporately, rather than focusing on all the complexity, which is what most folks do, if we could identify some very simple fundamental elements and work on those? Well, that's exactly where we're headed.
If you're finding these insights helpful, please share them with your friends and colleagues. Help your search engine find more content like this for you by hitting the like button before you leave. And if these PPI messages resonate with you, subscribe to this channel so you don't miss the next one. Until next time, my friend, be safe, stay humble, and make a difference.